equation are we going to use? Theta 2 pi r over 360. So what is our radius, Travis? Radius on this problem is the number 5. Good. All right, so we're going to plug that in. What's our theta, Mariah? Oh, you're absent. I'm sorry. Oh, no, you're not absent. You're good. So, Mariah, what are they? Good. 45. So the theta is 45 because that's the angle. Times 2 times pi. And Travis, you'd said 5. Good. Over 360. So now, I need to do some elimination. 2 goes into 360. How many times? 180. Good. 5 goes into 180. How many times? Anybody? Nobody? Oh, good job, Katie. 36. So now, 45 goes into 36. Well, what is a common denominator, common multiple in those? 9. Good job. Nice job, Sam. Great job. So 9. So this is a 5, and this is a 4. So our final answer is 5 pi over 4. 5 pi over 4. So you start with theta 2 pi r over 360 equals, and we plug in our numbers, 45 and 5. We do the elimination, and we're left with 5 pi over 4. And that's your final answer. You don't need to take it down any further. You could take 5 times 3.14 and then divide it by 4, but you don't need to. That is close enough. That's good enough. All right, so any questions on that problem there? No questions on that problem? Awesome. Awesome. So, let's get the next one. All right, let's do another one so just we can get some practice in here. All right, so let's say, all right, so let's erase this. Let's say I have all right, so now it's a little difficult, more difficult, gotta think. The radius is 10, and the arc measure, not the arc length. Remember, when you're looking for arc length, you have to use what equation? This one right here. Theta over 2 pi r, which is what we're looking for. If it's an arc measure, it's really the what? Because it's a central angle. What is it? Really, it's a, Tyler? 160. Good. All right, don't talk out, please. Make sure I wait until I call on you. All right, so let's use our equation. Theta over 360 2 pi r. Well, what is our theta? What is our theta in this problem? Matt Caldwell. I hope they prayed for your unspoken today. I really do. I know you always have one. So 160 over, so put a parenthesis around so we know, 2 pi, and then r is what? 10 over 360. Okay? Now what do? We just got to eliminate. Well, 10, take 10 out. You're left with 36 over 160 over 2. 2, this goes to 18. 18 and 160. Lower 160 to 80. Divide by 2. Divide by 2. 9 over 80 over 9. Can I reduce either one of those anymore? Does 3 go into 80? No, it doesn't. So we're left with our final answer of 80 pi over 9. That's my final answer. Okay? So I just can cross out because they're in fraction form. All right? Okay, so does everybody understand that? Does everybody understand how we would find the perimeter or the arc length? The arc length. So the arc length of that segment. That length is the actual distance walked on it, which is the circumference times that fraction, pi, or theta over 360. All right? Any questions? Look at example number 2 on page 401. Let's do a practice problem. Another practice problem. This will be your third practice problem. I want to make sure you get this because I won't be here to help you. So you have to make sure you understand. Please write these problems down. If you need to watch it a second time, you may. I hope it's only one time for your sake, as I know I am boring. All right? So here we go. So the problem is 110 and 12. So how do I find arc length? Arc length, not arc measure, arc length. Arc length, well, theta over 360, 2 pi r, right? So let's plug in. What is our theta? What's our theta, Jasmine? 110. Good. I hope you can read this. 110. What is, so put parentheses, parentheses, and what's our radius? What is our radius, Tara? 12. Good. All over 360. So start with crossing off 10. So I take 10 out of this, so it makes it 36. 10 out of this makes that 11. Good. Now, 12 goes into 36 how many times? 1 and 3. We're left with 3. 11 times 2 times pi. So 22 pi over 3. And that is our final answer. You check, if you check the book, you will see that that is the arc length. Now, class, one last thing we have to do. If you are finding the perimeter or the perimeter of the sector, if you are looking for the perimeter of the sector, and I'm sorry, I have to close that for a second. If you're looking for the perimeter of the sector, here's what you have to do. One more step. What's the whole perimeter of this sector? What is it? Well, it's this arc length plus how many radiuses? 2. Very good. So if I'm looking for the entire perimeter of my sector, it would be 12 plus 12, which is 24 plus 22 pi over 3. That would be the perimeter of sector. Okay? Is everybody? Everybody understand that? Okay? Good. Now, I would like you to do for homework. Okay? I would like you to solve number on page 402. 402, 6 through 10. And I would like you to solve number 11 through 18. And now listen carefully. You'll see on 11 through 18. I'm going to zoom in here for you. And you'll see this last thing. It says perimeter of the sector. All I want you to do is do number 11 through 18 and that last column. The very last column, which is perimeter of the arc. So you're going to do 6. Okay, so your homework, page 402, 6 through 10, and 11 through 18, and it's just the perimeter problems. Okay, so this is Monday's homework. Okay, hope you don't have any questions. I hope you enjoy. Please have a great day, and please don't forget to do your homework, because if you do your homework, I may, no, I'm not coming back from Hawaii, sorry. You're just going to have to watch